Okay, so I'm doing a presentation on atomic structure and bonding. This is for my assignment 10. It's going to be based on scenarios 3 and 4, which we'll get into later. Okay, so this is scenario 3. Okay, so scenario 3 says atmospheric ions are electrically charged electrically charged particles which occur naturally in the atmosphere. They form the upper atmospheric layers mainly because of the action of ultraviolet radiation from the sun, as well as in lower atmospheric layers as a result of radioactive radiation and cosmic rays. These cause ionization of neutral molecules or atoms. As a result, ions are formed. These ions almost instantaneously combine to form molecules with ionic bonds. So the first section is essentially just the process in which causes the ionization of molecules which combine to form ionic bonds. So ionization is a process which creates ions. So what is an ion? An ion is a molecule of an element which is essentially an element but with the greater or lesser number of electrons when compared with the number of protons. Okay? So the second section also then talks about ionic bonds. So this is the main section because obviously we are talking about structure and bonding, okay? This is about two ionic elements which require a specific number of electrons to fill out their outer shell, come into contact through electrostatic attraction between positively and negatively charged ions. They share electrons so that the outer subshell is filled, and then bonded ions so the bonded ions are now stable. In most instances, this is to stabilise the element by filling the last subshell of the atom. It produces a positively charged cation, which is the metal, and a negatively charged anion, which is the non-metal. Okay. So the best example of a ionic bond would be sodium chloride, which is most commonly known as table salt. This is done using sodium and chlorine. So if you look at the electron configuration of sodium, it is, this is the first section, but the important bit is the last subshell. So we've got 3s1, so it's in the third shell, and it's in the s subshell. So for this to become stable, to fill out the subshell, it'd either have to gain one electron or lose one electron. So it'd go to either the last part being 2p6 or 3s2. Okay? So the second element is chlorine, which is the non-metal. So the last subshell is 3p5. So that would have to, so obviously it's in the p subshell of the third shell. Okay, so obviously we're not going to be losing 5 electrons because that would take too much ionization energy. So the easiest, fastest way for us to do it, to fill out the last subshell, will be to gain 1 electron. And obviously, as we know sodium only has to lose or gain 1, so obviously that can lose 1. So we can have a look here. So sodium and chlorine then come together. The sodium loses an electron, which makes it positively charged, because obviously electrons have a charge of -1. So if you lose a -1, you're going to gain +1, because obviously you're losing a -1. And then chlorine will then gain this electron, so it'll gain a minus, so then that'll become negatively charged, so that'll be the negatively charged anion, and that'll be the positively charged cation. And so obviously this plot positive and negative charges, because the positive and negative then through electrostatic attraction pulls them both together and makes them bond. But they're not sharing the electron, but they give away the electron, and this change in charge makes them both come together. So that forms to create sodium chloride. Okay, that's how ionization, ionic bonding works. Okay, so the second scenario 4. So it says a polymer is a substance which has a molecular structure comprised of a large number of identical molecules covalently bonded together to form a long chain structure. Many synthetic organic materials are polymers such as nylon, polyethylene and Kevlar. So this isn't massively important. The point we're looking at right now is covalently bonded together. Okay, so covalently bonded, so we're going to get to that in a minute, but obviously it says the extra explanation is covalent bonding. So I need to explain what these are, the formation of different types that can exist, examples single and multiple. I need to do some research and explain to you essentially 4 different examples of this. Okay, so first off, what is a covalent bond? So a covalent bond is like an ionic bond. Its purpose is to fill out the outer shell of the element and stabilize it. Okay. In this case, the atoms do not pass electrons between the two. They actually share them in kind of like a symbiotic relationship. Obviously, it's not between 2 organisms, it's between 2 different elements. Okay. So the first example is hydrogen. So obviously it doesn't show it here, but hydrogen has one electron. It has one electron and one proton. Okay, so its outer shell has 2 in it. So we need to fill that 2 or lose 1. So for covalent bonding, it would have to find another element that it can share 1 electron with. But obviously hydrogen is the only element in the periodic table that has 1 electron. So it have to share it with itself. And that's what it does here. So as you can see here, so it's going to get a full outer shell of 2. It shares 1 electron with the other hydrogen, which then shares its electron, and then they both coexist and are bonded together and share this 1 electron together. Okay. So the second example, slightly more complex, but pretty much the same process, is oxygen. So oxygen, its outer shell at the moment has 6. As we know, it needs to have 8 in its outer shell in total to stabilise. Oxygen does. Okay. So in this process, both oxygen elements will then share 2 electrons with each other, meaning that they then both have a full outer shell and can stabilise. As it's quite easily noted there, obviously, with the 2 passing over with the 2. And then next, obviously, we have H2O, most commonly known as water. So this is between 2 different elements this time. So we have oxygen again, as before. It only has 6 electrons. Obviously, like we said before, it needs to have 8. And hydrogen, as we said before, needs to have 2. Okay, so in this instance, they need 2 different hydrogen atoms to bond with 1 molecule of oxygen, and that stabilises it, and they all work together and stabilise and become 1 compound. Okay, I mean 1 molecule, sorry. Okay, and the last one is carbon and hydrogen. So carbon has a atomic number of 4, so it has 4 electrons. It needs 8, as we said before. The outer shells always need 8. So in that case, you'll need to find 8. Obviously, you can do this possibly using 2 oxygen atoms and sharing 2 that way, but it's usually easier for it to bond with hydrogen. And in this case, obviously, hydrogen, like we said before, needs 1 electron to get an entire outer subshell, and carbon, as I just stated, needs 4 electrons. So in that case, we need 4 separate hydrogen elements to come together and bond with the carbon for it to fully complete its outer subshell, and all 5 of them can work together and stabilise in that way. Okay, that's essentially the process and way and how covalent bonding works. And yeah, thanks for watching the presentation.
That's it.
Yeah, you don't know.
Okay.